Welcome to this afternoon's A over IP webinar. My name's Clive Coldwell. I'm Group Editor of AV Magazine, and in the next 40 minutes or so, we plan to talk about three main things. When you select AV over IP products, the different options available to you, and AV over IP's management and control elements you must be aware of. To present and discuss the issues, we have two speakers today, you may know actually, as Product Line Manager of Digital Media at Crestron. Alex Perez currently leads product strategy and direction for video solutions, including DM-NVX, Crestron's AV over IP solution. And Stain Holmes is Director of Product Strategy at AV and Digital Workplace at Creston Electronics. He started working in the company's engineering department over 20 years ago, so he's had a hand or say anyway in the development of just about every piece of technology the company has released since then. Welcome, gentlemen.
Thank you.
Thank you very much for having us.
Well, quickly before we start, I've just got a few housekeeping items to cover, as per usual. First of all, today's webinar will be available on demand after the live session, and it's accessible through the same link you're using now. However, we'd love to hear from you today, obviously, and if you have a question for any of our speakers, please feel free to send it through the Example Ask a Question tab at the bottom of the page. We'll be holding a Q&A at the end of the session. I may well feed in a few questions before that if the opportunity arises during the presentation. But if we don't get to your question today, we'll be sure to follow up afterwards, obviously. And finally, we'd like to encourage you to share today's webinar with your social networks, tell the world how wonderful we are and everything else. So without any further ado, let's kick things off. Over to you, Alex and Stain.
Great. Thank you very much, Clive. So starting off, we're here to talk about AV over IP, and really what that all stems from is the delivery of content. Content is surrounding us in every aspect and form of our lives, whether we're watching it on television, looking at our phones, or even just walking in the street looking at signage. What that stems from really is a source. And those sources can be, like I said, my laptop, my cable box, my Xbox or gaming controllers, or an old camera. That's a joke, by the way. But the key to these sources and the key to this content is that they have 4 different types of data. And that data is audio, video, control, and USB. The challenge in the Pro AV industry and the solution that we've had to provide for the last 12 years is to take those forms of data and put them on a single wire so you can transform many different applications. And those applications exist in the education markets, enterprise markets of corporations, live concert venues, arenas, command and control centers. That's just to name a few. But the key to those applications and the key to those experiences is taking content driven by sources and delivering them to many displays to create unique experiences. Historically, and still today, those experiences are delivered by HDBaseT solutions or point-to-point matrix solutions that provide the flexibility and capability to do so. But AV over IP really takes that to the next level. What AV over IP allows you to do is take those experiences and transform them and transport the audio, video, control, and USB on an IP network. What that provides is the consistency and the experience to manage the devices flexibly and scalably. So you can create different and unique video and audio-visual interactive experiences throughout your day and throughout your life. So just to name a few of those types of experiences that we've seen transform with the AV over IP technology in the Pro AV market space, sports bars and distribution. As many of you have seen before COVID-19, going to a bar or a restaurant, there tend to be a lot of displays, especially in sports bars. And that was just showing different games and all different attributes. But of course, there's a limited number of games that are on compared to the maximum number of seats or how many displays can be delivered. With AV over IP, it allows you to deliver that experience cost effectively and seamlessly. So you could scale as the business begins to scale. Also, museums now are looking for interactive audiovisual experiences by clicking through or actually providing touch experiences to the end user or the consumer. That's also occurring as well. And then in university and e-gaming and medical applications, the need to make sure that there's perfect quality, very low latency to show and teach in those different applications and experiences, AV over IP can provide solutions in those realms. So now to talk about the different types of AV over IP, Stein will take over.
Yeah, so actually within AV over IP, you can classify it in kind of 3 different types. And these types are being determined by the codec that is being used. The word codec actually is an abbreviation from 2 things. It's compression and decompression. And when you compress video, the codec determines actually the bandwidth, the latency, and the quality. And all 3, they go hand in hand. So if you look at the first type, is the sub 100 megabits per second type of AV over IP. This is generally very low bandwidth. It is below 100 megabits per second, even much more below that. We'll get to that in a second. It does, on the contrary, on the counter side, it does induce higher latency. This can go into 100 milliseconds, soon as 50 milliseconds, even up to a few seconds, depending on how far and how much you compress. It still can give high quality video, and as a high scale, I should even say super high scale. Some examples of these type of codecs is the H.264 and H.265, but also VP9 and AV1 can be falling under these low bandwidth codecs. A second group is the 10 gigabits per second, and there's a slight typo here. The B should be a small b for bits. It's 10 gigabits per second. This is, of course, very high bandwidth, but on the top side, it has very low latency. Though high quality video, but limited in scale. And we'll get to that a little bit later on. And then the third group is the single gigabit per second group. This is what we consider kind of medium bandwidth. Why? Because the majority of the networks have 1 gigabit available today. It is still low latency. You have medium to high quality depending on the actual codec you use. If you use because JPEG 2000 is around for many years. The initial JPEG 2000 codecs are medium quality. But today, with today's technology and improvements in that codec field, you now can get high quality to very high quality, which is close to equal the 10 gigabits per second solution. And here we can still consider it as high scale, but again, we'll get to that in a second. If you look at the use cases, the sub 100 megabits per second video streams can cross the internet, can go to the other side of the world, even through 4G, because the bandwidth is so low. And then, of course, with the higher latency, when you stream content to the other side of the world, the latency doesn't really matter that much. Although when you do that in a room, then latency might get painful. Think of mouse lag. When you try to control your mouse and it's lagging for half a second, even that is a terrible user experience. The single gigabit per second solutions perfectly fit on local area networks. As I said today, the majority of the networks available in enterprises and higher education are at least a gigabit per second per link. And even controlled wide area networks are also part when you stream in between campuses. That is also still possible with a 1 gig solution. 10 gig solutions, though, because of the extremely high bandwidth they use, they're kind of limited within a local area network, and even then it's pretty limited. So if you look at an example, let's stream a 4K 60:444 video, which is about 18 gigabits per second. If you run that through an H.264, H.265 codec, so to get into a bandwidth range below 100 megabits per second, you're compressing a factor 200 to 1. And this is one of the reasons as well why there is so much latency, because the codec needs to compress it very tensively to get to those low bandwidths. Of course, the advantage is that you can get it through the internet anywhere in the world because the bandwidth is available. If you put that through to a single gigabit network, you're compressing in a ratio of 20 to 1. Which doesn't take up that much time. So that's why latency in those solutions can be very low. And then when you put that through to a 10 gigabit codec, you're still compressing. An 18 gigabits per second signal cannot go uncompressed on a 10 gig network. So you're still compressing in a ratio 2:1, but then of course, because the compression is only 2:1, latency is very low to that sense. Now, there is another thing that needs to be highlighted, that is that it's unicast and multicast. These are technologies on the network. So unicast is kind of a connection point to point between a server and a client, or between the encoder and the decoder. And each client receives a unique stream of that same content. Now, it has advantages, and that is you, as a user, as a client, you have full control of the content without affecting the others. By the way, this is what Netflix and YouTube are using, by the way, because when we all are watching the same movie, if you would pause the movie, nobody else's movies is paused, because we all get a unique stream of that content. The disadvantage, however, it's very contradictory, you might think, it doesn't scale very well. Specifically, if you look at the 1 gigabit per second codecs and the 10 gigabits per second codecs, it scales good for the low bandwidth codecs, the sub 100 megabits per second, like Netflix and like YouTube, but because the bandwidth consumption is multiplied by the number of listeners in a unicast. So if you would stream if you would unicast stream a 1 gig solution to 5 clients, you're already consuming 5 gigabits per second. So that's why it doesn't really scale that well. Not only that, you need a lot of horsepower on the encoder, because it needs to generate from that same content multiple identical streams. But as I said, it's well suited for delivery of media on demand, but it can have issues when synchronization of live content is a concern. Now, multicast is actually a single server broadcasting across the network. Think of the good old coax RF distribution systems. You kind of tune in as the individual clients. You tune in or you do not tune in, and the broadcast here is handled by the network switch, not specifically by the device generating the stream. It's done by the actual switch, and the total bandwidth is just the size of a single stream, and that's why it's used in a single gigabit per second and the 10 gigabit per second solutions. You very often, or you kind of always, have multicasting. Although multicasting does require specialized network hardware and a more in-depth network configuration. So speaking of the network, Alex.
So now going into it, Stein really went through all of the types of AV over IP on the network and or in for sale today. And those are dependent on different codecs, different bandwidths, different latencies. But the key here, as I mentioned in the beginning, is a three-pronged approach for AV over IP. It's the flexibility, the scalability, and the management of the devices on the network. So let's first start off with the flexibility. Flexibility is commonly defined as the ability to adapt to changes. For networks, flexibility refers to the ability to adapt to available network resources, such as flows or topologies, to change design requirements. So for instance, if I have an organization that has a certain number of rooms or a certain number of displays, and I want to change that in a year because my organization is growing or we're contracting for some reason, or the space is going to be used in a different area, I want the flexibility to change that experience. That's what AV over IP provides. In the top left corner, I provided a star topology. It's a simple network switch with AV over IP endpoints. The key with AV over IP is that any device on a network switch can be a transmitter or a receiver. You're no longer fixed to a chassis matrix where you have a fixed number of inputs and a fixed number of outputs. Now these inputs and outputs can be flexible. So if I decided to have a single encoder streaming to 7 decoders or 7 displays at the same time, I could do that. Or if I decided to have 7 encoders to switch between multiple sources of content to a single display, I can also do that. It's flexible. Furthermore, as your organization or as your applications continue to expand, you can now grow your network topology to accommodate not only your AV over IP devices, but also your wireless access points, your end user devices, your audio over IP devices. Basically, the entire system can come together to make a cohesive, easily flexible system that can change as your needs change. So in this tree topology, you see 3 network switches with multiple AV over IP endpoints. As long as you're designing the system to ensure that the bandwidth and its needs are allocated to be met, you can make sure that each of those systems are working effectively. And then furthermore, there's 2 other systems. These are daisy chain systems, where customers can take a single transmitter and then daisy chain them to multiple receivers to create different types of experiences. So 2 examples of this would either be a video wall. So I showed you a picture before of the sports bar distribution. Typically, sports bars have video walls on them. If you wanted to be flexible and change the different types of streams or different types of content that's on that wall, you could design that easily with AV over IP. And for other applications that we're seeing today, also in courthouses, where jury boxes meant for 12-person juries, each jury member is supposed to have a dedicated television to see the content, or a display in front of them to see the content that's being shown in the court case. Because of AV over IP and the flexibility of rearranging this, now you can deliver those types of experiences that were possible in the past, but they just were not as simple and cost effective to manage on the network. So with that being said, for the flexibility, the scalability now becomes endless. Basically, you scale based on your experience or based on the application that you want to provide to your end user. So in all of the applications that I spoke about previously and the applications I just mentioned, you can really change and design the system to work the way that you want to make it work, not the way that you're forced to make it work due to the technology. And that really is one of the benefits of AV over IP. And Stein can go into some of the scalability aspects of that when you're looking at network switches.
Yeah, correct. One thing to mention before is on the scalability, is also expandability. Imagine you have a fixed matrix solution, an 8x8, it's fully populated, 8 sources to 8 displays. And now suddenly you want to add an extra display. That means you're in an 8 to 9 scenario, but your matrix switcher is full. So you have to jump up to the next level, which is very often a 16x16. So you're going to have a lot of empty inputs and a lot of empty output just to add that extra destination or add that extra source. That's one of the advantages as well with AV over IP. You just can add one additional encoder or one additional decoder and your problem is solved. But as Alex says, also scalability is based on the actual network. And if you look here in front of you, that is an example of a network switch where you have 48 ports of 1 gigabit connections, and then you might have as well uplinks. These are connections to link switches together or link such what we call an edge switch to a core switch, which is your central based switch that links to all the different multiple switches. So these are called uplinks, where you can get data rates up to 40 gigabits per second, even 100 gigabits per second are possible, but are pretty expensive. Now, one of the things that are a kind of a requirement within AV over IP is that the switches are non-blocking, meaning in the sense that every port on this switch, in this case 48 ports, can run at full speed simultaneously. So all the 48 ports of this 1 gigabit switch can handle 1 gigabit per second bandwidth at all time simultaneously. Now the challenge comes when you are going to use those uplinks, because those uplinks have limited bandwidth in a certain way. Because if you have, for example, an uplink of 40 gigabits per second, you cannot send those 48 streams over that uplink, because that would mean 48 times 1 gigabit per second, getting into 48 gigabits per second. So in this scenario, you have to limit it to the single switch to about 40 endpoints, because 40 times 1 is 40, and that fits still on the uplink. Now, this is a challenge specifically in the 10 gig scenario, because it gets very expensive. If you look at the scale on the left side of single gigabit solutions with those 40 gig uplinks, you can have on each edge switch, you can have 40 endpoints, getting you a total of 80 endpoints. In a 10 gig solution, however, with 40 gig uplinks, you can only have 4 times 10, so only 4 endpoints on both edge switches, which get you up to 8. Of course, within the 10 gig environment, very often you also have uplinks to 100 gigabits per second, and then you can get into 10 endpoints per switch, but still it's kind of limited, and these are very expensive, these uplinks. Now, talking about all these, so many devices scale, many devices on the network, so these devices needs to be managed. Alex, how do we manage it?
Yep. So manageability now becomes much simpler because for two reasons, right? One is because everything is converged on the network. We've had the ability now to have all devices, all endpoints localized to the network switch. So whether that's your audio over IP, your audio and video over IP devices, or your personal devices or laptops, each of those devices are on the network. Now that they're on the network, you can have on-premise servers manage those devices, software applications manage those devices, and in Crestron's terms, we have multiple products. One is DMNVX Director, which allows you as a software management platform to see all of your encoders and see all of your decoders or transmitters and receivers on the network. Make sure the devices are set to the right mode and route. It gives you really a system level view now because everything is manageable on a network. You can see the entire system, not just a single isolated ecosystem. Furthermore, because it's on the network now, you can manage things with standard APIs and standard protocols. So devices can now be discovered, easily joined to the network, and it just increases your manageability, but it also simplifies your installation and design when you're installing these devices. So what I'm speaking towards the APIs right now and the manageability on the network, I'm really talking more on-prem. But the network flexibility actually allows you to extend beyond that. So with that extension beyond that, it really brings us to the cloud. And Stijn is going to talk some more about that.
Yeah, so thank you. As Alex said, managing through the cloud can give some advantages as well. One of the benefits of cloud, it can lead to a lower total cost of ownership. Not only that, specifically in these times, COVID, past COVID or post-COVID, where we want to spend limited time on site, again, cloud can help us drastically in spending less time on site to deploy and get things up and running. I'll show that to you with an example. To configure devices, AV devices, you need to be on the network. You need to have access through IP to that device, open a browser, go to the device and make or put the settings and configure the device onto the network. Now, this requires you to be within that local area network. There are ways to do that when you're remote, but that means you will need to have VPN connectivity towards that network. And as an installer going to a large corporate, this large corporate will not easily give you VPN access into their networks. So the best way to do that is actually with cloud, because with cloud, what happens is that the device reaches out towards the cloud. And when it does that, it creates a secure TLS tunnel. And this is very often not an issue for network firewalls. And think of this, I'm going to say an analogy. If you travel to the United States, for example, in order to get into the United States, you need to fill in that ESTA form, you need to get that visa. When you walk into the immigration officer, you've been asked a lot of questions, and then you might be able to get into the country. But leaving the United States is very easy. You show your passport, they control the stamp, and up you go. And this is pretty much the same as network security. It's very difficult to get inside the network, but it's kind of easy to get out. So, and this is where cloud gets into the advantage. So the device reaches out to the cloud, it creates a secure TLS tunnel, and that's how you then can reach to the device. Now, it goes even a step before that. Configure your device before it is actually installed. When the device is still in the warehouse, without a cloud, that is not possible. Without a cloud, the device will physically need to be on site, and you physically need to have access to the device in order to start configuring it. With cloud, it does not need to go that way. With cloud, you can simply, when you order the devices, you receive a list of the MAC address and the serial number by that device. Based on that, you can claim that device within the cloud. And what kind of happens is by claiming it, that device starts to live virtually in the cloud, like it would be connected onto the network. So then you can push your configuration to that device, or you can start to configure the device while it is still on road towards site, for example. And then when the device finally is going to arrive on site, at that point in time, the only thing you need to do is to connect that device onto the network. And by doing so, the device will then reach out to the cloud, represents itself or identifies itself with its MAC address and serial number. And based on those two parameters, the cloud knows what device you are and which configuration is actually part of that device. So as soon as that's okay, the cloud will then send the configuration to the device will boot up with that configuration loaded, and off you go. So this would mean you do not have to send your highest paid engineer on site for startup. We know that in the IP phone industry, companies like UPS and TNT and FedEx even provide services to those manufacturers that they do the installation, because it just requires opening a carbon box and connect the device onto the network, and all the rest is done automatically through the cloud. Another advantage of cloud is because with updates of firmware, because the firmware adds features, it improves things, it eliminates bugs and so on. So again, I'll give an example. DMNVX we released in 2017. This is our AVoIP solution. Only 2 years later, in the beginning, in January of 2019, we had more than 140,000 devices installed across the globe. Now, a month later, in February 2019, that was during ISG, we introduced or we released a new firmware for all our NVXs, which drastically improved the codec, going from a JPEG 2000 codec to a much newer, more advanced codec that improves the quality, that the quality of the video is now identical to the source. Now, everybody wants to have this firmware, but what had to happen is that, first of all the integrators had to call up their end users, all their clients, and schedule a time when that meeting room or when all these rooms were available to do that firmware update. Then the engineer had to make sure he downloaded the right firmware from our website, and then he had to get into the van and drive to all the sites. And when he arrives on site, he has to update device by device by device. Well, with cloud, this is no longer needed. With cloud, you simply had to go to the cloud area of that specific site. You schedule within the cloud, you schedule a time and a day and a time when that room are free, very often in the middle of the night. And the firmware is already available within the cloud. We as Crestron put those firmwares in your cloud instance, and you just by a drop down select the right firmware, you save it, and then in the middle of the night, when you scheduled it, when no one is using the building or the room, all the devices are being updated. So by this, again, no need to go on site. You gain a lot of time by doing so by using the cloud. And not only that, also saving a little bit of ecological footprint by not having too many vans on the road. Now, firmware also not only gets improvements and extra features, but also firmware brings in security patches as well. So, Alex, can you give us a little bit about security? Because putting video on the network does require some serious security.
Of course, yeah. So I mean, everything you just mentioned, from putting the devices onto the network to them being able to reach the cloud, so you can manage them just like you manage every device in your daily life. You need to make sure that we're keeping the content secure and that the devices themselves are secure. So we want to touch upon one thing about AV over IP, and that's the fact that while the devices now are on the network, that means that security is more of the utmost importance, to ensure that all the streams remain encrypted and they cannot be intercepted, that the devices themselves are secure and are allowed to be on the network. So if you're in a corporation, whether that's the banking and finance industry or any other enterprise industry for that matter, you want to make sure that the devices that are on your network are secure and cannot pose threats to the organization. So making sure that AV over IP devices support standards like 802.NX or Active Directory or TLS authentication as well as AES encryption for the streams, will ensure that all the data is encrypted. And if an executive or a CEO is presenting their presentation while connected to the device and it's being viewed by the audience, someone else cannot be intercepting that stream. So that's extremely important through an organization. So we've talked a lot about generic AV over IP applications throughout the presentation. Stein and I are from Crestron Electronics, and we just wanted to highlight really what DMNVX is and what Crestron brings with AV over IP. So DMNVX is Crestron's AV over IP solution. It was the first AV over IP 1 gigabit solution with 4K 60, 444 and HDR support. It was the first AV over IP solution to utilize all of the full enterprise grade security, like I mentioned before, that allowed you to connect to the cloud and on-premise devices securely. It also was a single all-in-one SKU. This is a big drastic change for the Pro AV industry, because what it allows you to do is provide a single box to stock. Regardless of whether you want to set the device to a transmitter or a receiver mode, now with AV over IP, you can have single SKU orderable devices that can be very flexible. That flexibility also brings in all of the features and data that I mentioned before regarding USB routing, HDMI or video switching, and control. So now that you have flexible USB routing, we also have flexible audio routing with built-in DSP options and Dante audio. So the key to AV over IP is really making sure that you can deliver the experience that you want and that your end users deserve, so that it can be transformed to meet any of the design expectations that you may have. So walking you through now the designing aspect of AV over IP and what really NVX provides, Stein will show you how to build those systems up so they can really become an integrated solution.
Yeah, so quickly going through our DMNVX ecosystem, it starts with the most simplified encoder, the E30. The E30 takes in HDMI up to 4K 60, 444 and HDR and converts it into a 1 gigabit per second video stream. On the other end, then you have the D30, the D stands for decoder. It then takes the stream, it picks in that multicast stream, and then it converts it back into HDMI, which you then connect to your projector, display, or your surround sound system, your AVR. But also that D30, in case specifically for projector or for a professional display without speakers, or you need higher volume in that room, that D30 also has an analog audio extraction. So it takes the audio off of your video stream and converts it into a 2-channel analog audio that you can then bring to a power amplifier and the speakers in the room. The next product in line is what we call the DMNVX 350. It is identical as an E30, but it adds an additional HDMI input. So you can connect 2 sources. Doesn't mean it streams the 2 at the same time, but it can work like an in-room switch as well. So you can select what source you're going to stream onto the network. But that 350, another difference with the E30 is that 350 can not only be set as an encoder, but it can also be set as a decoder, so as a receiver. That's what Alex was referring to, that single SKU that can be used as both a transmitter or a receiver, depending on how you configure it. So the 350, another thing that it has, besides decoding, it also has the capability to create up to an 8x8 video wall functionality. Not only that 4K scaler with video wall functionality is part of the 350, but it also adds, of course, because we have that additional HDMI input, you can add in that room, you can add additional sources in order to present in that room. So that room can then take and stream sources from the network, and then, of course, local sources that you have within the room. Another feature that 350 adds on is USB connectivity for an interactive display, for example, or a room camera over USB that you can use with unified communication that runs maybe on an in-room PC on the top left there. So that USB signal from the touch can go through the in-room PC and as well as the room camera, because it kind of creates a virtual USB hub. Maybe we have on that table a mouse and keyboard, which we also want to add to control that in-room PC. But there are not sufficient USB ports, or you want to use that mouse and keyboard also in a KVM type of application. So we also added the ability to use one of our USB extender solutions, the USB NX2, to get that USB onto the network and then can be taken off by either an encoder or a 350 in that case on the top left corner, but also you can add an additional USB extender specifically next to the E30 for a PC over there. So now you can switch that USB signals, whether it's the camera or the interactive display or your mouse and keyboard. DMNVX has the power to completely distribute and send that USB signals to anywhere you want it to. The next product is the 351. The 351 is kind of identical to the 350, but it adds surround sound down mixing. It has a DSP built in, so it can down mix a surround sound source and send both streams, both the surround sound stream and the down mix stereo stream onto the network. Meaning I can, for example, in a residential environment, we are watching with the family a movie in the home theater or in the living room in surround sound. Now it's dinner time. So we can go, so I go to the kitchen and prepare dinner, but the kitchen is a stereo room. I still want to continue to watch the movie over there while the rest of the family stays in the home theater. Well, I do not have, or the home theater will not suddenly drop down to stereo. No, the home theater will continue enjoying surround sound while I'm in the kitchen listening to the stereo side of this source. Then another product that we released together with Intel. Together with Intel, we designed the D80, which is a decoder that fits in an Intel OPS slot, an open pluggable specification slot that fits in those displays. So the display will then power the D80, of course, receives the audio and video through that D80 decoder, and of course control as well, and USB in case that display is a interactive touch display. The USB information can also be passed on to the source. Then the last product in our DMNVX portfolio is the 352, and the 352 is very similar to the 350 and the 351, but the 352 adds the ability to interject audio from any sources connected onto the NVX network onto your Dante or AS67 audio over IP solutions. Not only that, not only sending audio from any connected source into the NVX network, but also receiving stereo audio from the Dante network or the AS67 network and then send it to any of the decoders within the NVX environment. By the way, this summer, not in 2 months' time, we're going to release a firmware for all the NVX units that they will all be AS67 compliant in the sense that then even an E30 and a D30 will be able to get audio in and out from your AS67 audio network.
Yes, so actually right on that, Stijn, a question just came in through the chat from Stephen regarding interoperability and standardization of the technology as it develops. And I think that AES67 is actually one of the perfect examples to show how standardization is becoming adopted as part of the technology to integrate with other environments. So audio over IP systems really have standardized on 2 forms of technology. That's Dante audio, and the standard for that is AES67. And now with AV over IP systems adopting AES67 or having adopted already AES67 natively, that really provides interoperability and flexibility between the audio systems and the video systems, and it's definitely more apparent now than it was in the past. And with adopting solutions like modules that slide directly into the display, or the ability to adopt standard interfaces like HDMI, USB-C, and other interfaces, I really see standard formats taking off with AV over IP. The industry has really been very successful with the ability to interoperate with each other, and that is through all forms of communication, whether that's through APIs to control it, or the ability to mix and match audio video systems. And I do see that becoming a standard moving forward, and having a better interoperability between third-party manufacturers or in different manufacturers for both control audio and video.
Yeah, it's Clive here actually. That's a good point, isn't it? You know how AV over IP works in in mixed IT environments? Seems like an obvious question to ask, but it's one we get actually a lot of the time. Just what areas of the network are interoperable and which obviously conform to general networking standards and keep AV networking content and functionality to one side.
Yeah, it's such a great point, and it's really important too, because you have to understand what you're putting on the network. It was kind of like what I mentioned before about security, making sure the devices are secure. From the interoperability perspective too, because you could be, as a designer, installing extra boxes that you really don't need, because on the network they talk to each other. So it does provide that greater flexibility once the devices are interoperating and they're integrating standards like AES-67 or standard APIs that can afford the ability to easily control them. So with that being said, there are, just to continue to what Stein mentioned about the integration, really just talking about individual devices, but more from an agnostic perspective. Crestron is trying to do a few things here. We've been in the video industry, or at least in the video space, for Pro AV for a very long time now. And as we have grown, we've also seen customers grow and provide successes in different types of experiences that they were not able to deliver before. So on Crestron.com, we have many customer success stories for AV over IP and also for other types of systems, whether that's unified communications, HDBaseT extension, air media, wireless presentation, just to name a few. But what we really do is we want to provide are the resources for you to see the different types of experiences that you can provide to your end users, and also just share and collaborate amongst different people, so that everyone can share in the ability to move the industry forward and to bring these new experiences alive. With those customer success stories, we also want to make sure that we are educating as well. Moving the industry forward. So we are providing a number of design guides and tools that are free. They don't require any login on Crestron.com, and those are white papers, design guides that provide different applications and system integration designs, as well as network switch guides. And we know that the network is really something that in the AV industry has been seen kind of as a black box. We put it on the network and everything just works. But it is so important to understand how the network is used, how to set up the network, and how the whole system ties together. And like I mentioned before, that really brings the entire solution together, and it will make it more cost effective in the overall design and solution. So that being said, I want to say thank you for having both Stein and myself here today.
One thing I was going to ask you, actually, if I may, gentlemen, is that, hopefully this is not a noddy question, but are you looking at sort of typical types of entry-level approaches to AV over IP, or is best practice approach to adopting AV over IP not that clearly cut? Is that something that evolves as time goes on, or is there a clear need according to the application when you just say to yourself, well, we need to do that we need to have more flexibility and think twice about how we're using our network?
So I think it's the latter. There are many applications today and there are many applications today and in the past that are working perfectly with HDBaseT solution, point-to-point solutions, really that commoditized experience. But then there's also experiences like command and control centers, e-gaming arenas now that are kicking up. Many experiences that have to have a large number of displays but a few number of sources. I call those asymmetric designs. That's like when you have 2 or 3 sources but 100 displays. That's where the benefits really push to AV over IP. And in the industry, it was kind of like a catch-22. If you wanted to scale, you had to either put a ton of matrix switchers together to build that experience out, or you had to look for a different type of solution to deliver it, and maybe you're sacrificing bandwidth or latency, what have you. But now, with the industry moving forward, technology increasing, you can really provide both of those applications and experiences at the right price and in a simple solution.
Well, it's just a slight aside, actually. Paul from Dialogue has said, can you give an estimation of end-user pricing, or is that an impossible task?
Well, it kind of depends, of course, on the entire. It's giving you the price of a box doesn't really give you the scope of an entire project. But I think you have to start off with a few 2,000-3,000 euros up till, depending on, again, the size.
I mean, one of the things that struck me when you were talking about earlier was the, one that, again, another very often asked question is, what about quality of service on the network? How do you maintain it? And what elements of what procedures do you put in place to maintain delivery? Now we're looking at services now more than ever. I think that's probably high on the agenda, isn't it?
Of course, yeah, and that all begins in the beginning at the design phase. All right, so it's understanding what's going on the network, what devices are going to be there, and what kind of content you're providing. So actually, this kind of ties into a few questions that are in the chat right now regarding USB 2.0 and secondary audio with AES-67. Each of those different data paths have different quality of service, and maybe USB is more important to you than video, or the NVX stream is more important than another stream on the network. And just knowing what those streams are, knowing what the diff serves are on the network, and this is kind of what I was talking to about, making sure you're either working with the IT team or you're educating yourself on how to be better at networking and understanding the protocols on the network. That will allow us to move forward in the industry, but also through designs to make them simpler and easy to install.
How good are IT network managers at understanding AV requirements?
So the IT managers, I would say, are very good at understanding the IT requirements. The AV requirements have always been the dealer or have always been the designer or the consultant, because at the end of the day, they're who's delivering the end user experience. Right, that one-click join, or I walk into a room and the room just magically lights up. Those are special experiences that really the designer of the room are the ones that have to build that out. But what's important for the IT manager, and what we've seen the most success on at Crestron, is the ability to talk up front before you're getting into an application, or before you're even stepping into the design. Just knowing that AV over IP is the right solution for you. And knowing who the contact is in the IT segment. And then once you hand over, Crestron has a simple sheet that basically says that the 3 settings that need to be on the network, or that need to be controlled on the network, and the amount of bandwidth that's required. Once they have that information, I'll quote an IT director from a university right now. He said it was as simple as installing one of his wireless access points. At the end of the day, he thought of it as an endpoint. He knew exactly how much bandwidth it needed and what settings he needed to push to the box, and it goes from there.
I mean, it's interesting, it leads very nicely up until what you mentioned earlier about security, content, and device. I mean, that's where you probably, AV clashes with IT somewhat in the question of security and over security in the eyes of some. I can imagine, preparing a device off-site and making sure it's secure and the hardware loaded is a relatively straightforward operation. Content, however, I'm not sure how you would go about that. And how do you manage the two? Are they managed separately, or are they managed as that part of an AV service that looks upon the two and looks at requirements of one and clearly produces the hardware delivery solutions on the other end? I mean, how does it work?
So for content, especially in Pro AV, many of you on the call are familiar with, I hope, HDCP, and that's the production protocol for HDMI. So what's important for AV over IP, at least at the device level, is making sure that the communication itself is secure. That's HTTPS and a number of protocols. But there's individual protocols for each of the features. In content, the same thing exists. So there are protocols such as AES 128 or content encryption protection protocols. And for all of the data types that also exist. So for USB, you have to encrypt the USB data separately, then you would encrypt the audio data separately, then you would encrypt the primary audio video stream. And one thing that Crestron does is that regardless of the content type, so even if the content type, when I say content type non-HDCP or HDCP, for those of you that are familiar with HDMI, we ensure that as soon as we put it on the network, it is always encrypted, regardless of whether it's encrypted coming into the devices. And that ensures that there's a really an extra level of security when the content is on the network, so we can ensure that we are always secure.
That's good. That's quite a question that comes to us again a lot of the time as well. The general business questions, but also they're focused on how AV and IT work together and where their expertise lacks and where IT can help them and so on. But security is about the biggest issue at the minute, as is the cloud, of course.
Definitely. The cloud security, I mean, those are three talking points: knowing the network, cloud, and security, and they're in everyday life. Right, especially during COVID and the economic times that we're in right now, that was something that was being brought up on the news daily. And these are different types of experiences that you start living through, and we grow not only as individuals but also as an industry together.
Well, in a sense, if you're looking at remote production and applications and dealing with the fluid structure of a company, presumably being able to use the glue of AV over IP is one of the elements, one of the ways to go, but that does sound like a massive oversimplification.
No, I think you're right on. Right, I mean, it's technically what we're using right now to do this broadcast and webinar. There's like Stein mentioned in the beginning, there's so many different forms of it, and they're just used in everyday life. But you're right. There were at least in the United States, they had the football draft. And that entire football draft was done remotely by producers sitting in their garages using AV over IP systems. So those types of experiences in the past would have been very difficult to deliver if we didn't have these types of systems available now.
Presumably, we want to collaborate more effectively. They're going to have to be much more robustly put in place.
Definitely.
What are the biggest challenges you come across with AV over IP? I mean, primary one for us is understanding it. It's taken months and a couple of supplements to get to the bottom of where some of the elements of AV over IP are coming from, because you've got this tussle between the business need for an explanation and the technical explanation of what actually this technology is, how you plan it, where it fits in, and how it expands. It's the world's worst IT conundrum, really, but especially so when it comes to AV.
And that is actually the answer as well, because if we look at our technical support department and all the questions that we get in around NVX or AV over IP, is 80%, more than 80% is about the network and the network switch configurations. It's that multicasting, it's non-blocking, is getting over into different subnets and so on and so forth. So that this is, it's more specifically the knowledge of the network and the configuration of your network switch that puts in a challenge today. To get them done. That's why we as Crestron provide these network switch configuration documents and files. So to help step by step to configure your network switch if you're not that kind of a network expert to do so.
Which sort of begs the questions about skills, doesn't it? What skills are going to be needed if you're going to be starting increasingly investing in this sort of technology? What skills are you going to need in-house or otherwise to be able to broadcast skills, AV skills, networking skills? What sort of skills are we looking at and where they're going to be coming from?
So I think that for the skills with AV, they've been formed over time. I think if anyone remembers back to the analog to digital transition, that was a huge skill and mind shift, where the basic AV concepts, remain with you, but there's a new way of doing things. And with AV over IP, it's still the same. It's a very similar concept where you keep the skills that you've learned over time, but then you put them to different uses and how to grow. So if I have to say two key skills, right? Number one is never forgetting what you learned. That's the most important thing. NVX is based on technology that we developed 10 years ago with DM. And we just made sure we carried through those experiences in the AV over IP realm. And the second thing is educating yourself about IT and about networking. There are some courses out there. There are very detailed courses like Cisco's CCNA classes, but then there are a lot of lightweight courses that give you the same education, but they're not as demanding. And Crestron also offers courses as well that give you basic understanding knowledge of the network for designing and deploying systems. So, but that's not just Crestron. Every manufacturer, I believe, in the industry now is offering those types of courses.
Well, you know, as your business is relying more and more on this stuff, and it's starting to be more flexible, and the business shape is changing, and demand and requirements are changing very quickly. Whether you use outside people or you're working with your integrator or manufacturer, whoever it may be, it starts to put a whole lot of pressure on what skills you retain in house and what skills you buy in.
Definitely, yes. There's and that decision is up for each business, right? Every integrator may decide to tackle that solution differently. What I will say is the network is not new to our industry. The network has always been there, in some way, shape, or form. Whether we were using it to control the devices, and now we're just using it to really tie the whole system together. Other types of services that you may look to add on are security services. We mentioned in a section here of the webinar that security now is becoming really important in the industry, and understanding that being secure on the network could mean a few things for you as a dealer. And after you install the system, are you sure that it was secure? Did you sign over and ensure that to the company? So there are security insurances that you now can provide as a service, as a dealership to the end user, and they can expect that back. So that's some idea of shifting in education that can add. And those services you may decide to bring those in house and offer them yourself, or partner with another organization that does the same.
That's good. Anything else you'd like to add, gentlemen?
I just want to say thank you for everyone that was out there today. It's been a pleasure speaking with you, Clive and Stein, and thank you for learning more about AV over IP and being engaged.
Thanks, gentlemen. Thank you for being with us today, everyone. Don't worry if you haven't managed to get through the questions. I mean, a number of them came through. We couldn't answer them all. We tried to answer them where we thought it was relevant to do so and meaningfully for people. But we will get back to everyone. Don't worry about that. But I hope today, I mean, it's a complex subject to cover even in an hour, isn't it? But I thought it was pretty good, actually. I had some good diagrams there and good reference material, I thought. Thanks, gentlemen. Really good. Thanks very much indeed.
Thank you.
Thank you.
And thank you. Goodbye, everyone.